Welcome to the deep dive. Today we're plunging into something, well, truly revolutionary. It's the impact of artificial intelligence on genetic sequence analysis.
It's a massive topic.
Absolutely.
Yeah.
You know, genetic testing used to be this incredibly complex, often manual process. So slow.
Painstakingly slow, yeah.
But now it's rapidly shifting. It's becoming this efficient, data-driven field, and that's largely thanks to AI. So our mission today, for you listening, is to quickly get a handle on how AI is smashing through those old limitations, what it really means for healthcare, and maybe most importantly, what it means for you.
Right, the personal impact.
Okay, let's unpack this then. We hear AI is transforming, well, everything it seems. But what is it about AI specifically that lets it tackle something as intricate as genetic testing?
Well,
It really feels like we've jumped from using a magnifying glass to some kind of supercomputer almost overnight.
that's a good analogy, actually. The core thing here is AI's ability, its fundamental capability, to process and make sense of just vast amounts of genomic data.
Vast.
Yeah.
How vast are we talking?
Think about this. A single human genome. It has over 3 billion base pairs. That's an enormous library of information.
Wow, okay.
For a human analyst, sifting through that, it could take years. Literally years. And the traditional methods, they just couldn't cope with the sheer volume or the complexity, not with the kind of accuracy needed.
Right, just too much noise.
Exactly. So AI, particularly these advanced machine learning algorithms, they can scan this data incredibly quickly, minutes, not years. But it's more than speed.
Yeah.
They can accurately pinpoint tiny changes, these pathogenic variants that signal disease risk.
The really subtle stuff.
The really subtle stuff, yes. And complex biomarkers, too, these biological flags that help predict health outcomes or how a disease might progress. It's genuinely game-changing, making sense of these incredibly detailed genetic blueprints at a scale and speed humans just couldn't manage alone.
Okay, that's really powerful. So it's not just doing it faster, it's actually seeing things, patterns maybe, that we couldn't even perceive before.
Precisely. It unlocks a deeper level of understanding.
So let's bring this down to the ground level. For patients, for doctors, what does this actually mean day to day? What are the key implications we should really be focusing on?
Yeah, good question. When you connect these capabilities to actual healthcare, there are three, I'd say, primary implications, big ones. They directly benefit providers and patients.
Okay, what's the first?
First is enhanced diagnostic precision. Think about, say, a child with some kind of mysterious condition. Families often go on what they call a diagnostic odyssey, right? Years of uncertainty.
Heartbreaking sometimes.
It is. AI can dramatically speed up and, crucially, improve the accuracy of diagnosing genetic diseases. That means faster answers, more reliable results, getting onto the right treatment path much sooner.
Huge difference. Okay, number two.
Second, we're seeing advanced pharmacogenomics really come into its own. This is about enabling truly personalized medicine.
Right, tailoring drugs to the individual.
Exactly. Forecasting how you specifically will respond to a drug based on your unique genetic makeup. So hopefully, no more trial and error with medications. That means reducing nasty side effects and making sure you get the most effective treatment from the get-go.
That sounds incredibly promising. And the third.
And third is powerful clinical decision support. AI takes all this complex genetic information, which can be overwhelming, and translates it into clear, actionable intelligence for doctors.
So it helps them make better choices.
Yes, helps them make more informed, evidence-based decisions for treatment planning, tailored specifically to that patient sitting in front of them.
Okay, so what this all means then?
Okay.
It sounds like AI isn't about replacing doctors or clinicians at all.
Not at all.
It's more like amplifying their abilities, acting as a sort of force multiplier for their expertise, letting them apply their human intuition where it counts most.
That's exactly it. It enhances clinical expertise significantly. This shift is more than just, a technical upgrade. It's genuinely paving the way for a new era, an era of predictive and personalized healthcare.
Predictive. So getting ahead of problems.
Precisely. Moving away from just reacting to symptoms after they appear towards a proactive strategy. Tailored health management based on individual genetic insights. It's about getting ahead of potential health challenges before they become serious.
It really is astounding how AI is driving such a fundamental shift in understanding our own genetic blueprints. The level of insight, the precision. It was just science fiction a short while ago.
It really was.
This deep dive has definitely shown how our genetic future is being reshaped, like right now.
And maybe that leads to a final thought, something for you, the listener, to mull over.
Okay.
Given these rapid advancements, we've talked about AI predicting drug responses, enhancing diagnostic precision. How might this really fundamental shift in personalized genetic understanding change our proactive approach to long-term health and wellness in the future?
Huh.
What responsibilities might we have now to actually use this knowledge for preventative care?
That's a deep question. Definitely something to think about. What stands out to you from this deep dive? Ponder that, and we'll catch you on the next one.